There's been a lot of hype as well about the value of the gas, the value of the find. In fact, an article that Polly wrote in the Cyprus Mail on Sunday, I believe, quoted something in the region of $100 million, which is, shouldn't I say that?
No,
Okay, at today's gas price, the gas price has been dropping since about 2008. If we look at 7 trillion cubic feet, which is about 198 billion cubic metres, today's gas price at $3 per million BTUs is around about 23 billion. That's if you sold it today on the commodities market. And as I say, there is a figure being bandied around that it's $100 billion, but from what I believe, this has been based on what the cost saving of using Cyprus gas would be instead of liquid distillates over a 210-year period, which is about the life of the find at 7 trillion cubic feet. This would run the island for somewhere around about 200 years. So the savings, or the $100 billion that's been bandied around as a value isn't actually exactly correct. If we were using any gas now instead of liquid distillate, we'd be saving money. Liquid distillates are 3 times the price when it comes to an energy factor of what natural gas would, to generate electricity using natural gas. This is what the gas market did during the last 6 months of, the last 6 months. There's been a slow decline at around, down to around about the $3 per million BTUs. If we then looked at that from, if the gas was discovered at 7 trillion cubic feet in June, we're looking at about $36, $33 to $36. The gas price up there in US dollars per 1,000 cubic metres. So you can see that the 7 trillion cubic feet, if discovered in June, was worth 33 billion, and today's worth 23. I know it's not the right way. I know it's not necessarily the right way to look at it, but a figure has to be put on it, and this is I believe, a far more realistic figure than the $100 billion that's being mooted at present. Okay. The gas prices seem to, it looks as though the gas prices are going to remain under pressure for quite some time. They're much lower than the figure we had back in 2008, that was about $13 per million BTU. And the figures have been seen as reducing as a reflection of a number of factors. The credit crisis being one, the resulting recession, and the improvements in exploitation technology. And what happens when the gas price is high? They actually drive the push to discover more reserves. So, and that is exactly what has happened. The high prices themselves, they drove the technology that allows you to exploit fields that have previously been unexploitable, or seen as unexploitable. So these have sent prices coming down since 2008. And prior to the gas discoveries being made in Israeli waters, the island was looking at bringing on liquefied natural gas and building a regasification facility. This was put on hold, which at the time seemed to make quite a wise decision, because apparently we were going to be going into a long-term supply agreement, and at the time it was they decided to halt this, and at the time it did make very good commercial sense. Okay, now cancelling the supply agreement, the problem was that what this did was it stopped all concept development for building a regasification facility. So that was put on hold as well, which means that we've lost now 18 months to 2 years of any development being made from building a gasification terminal. Now everybody says to me, well, if we built a regasification facility, what would we be able to do with the equipment? Would we be able to use it? Well, you can, and we'll go on to that in a bit. But the problem is that, as I say, the EAC no longer has any gas planned. There isn't any. There is no long-term strategy or even short-term strategy on getting gas to the island. With the fact that Noble have now said that this exists, I believe the domestic strategy should be reviewed, and in some form of decision made as to what we're going to do about fixing the EAC's problem. Now, 7 trillion cubic feet, putting this into a life expectancy perspective, 198 billion cubic metres, as I say, would supply the gas needs to the island for about 200 years. And if we looked at the 30-year gas needs for the island, we'd look at about 30 billion cubic metres. That would leave an exploitable balance of 168 billion cubic metres. Now, if we were to build an LNG facility, which is one of the options and one of the will get mentioned, I'll go back to why I've said 30 years. The reason I've said 30 years here is the fact that most of the equipment we use in an LNG facility is designed for about a 25 to 30 year lifetime. After that time, we normally have to replace a lot of the major equipment, compressors, condensers, pumps. So we normally look at designing and building a plant for around about a 25 to 30 year life. So therefore, I've used a 30-year plan to allow Cyprus to use the gas in at its own discoveries for that period of time, plus exploiting and therefore having the potential to bring in export revenue for the same period of time. That's without taking into account that there will probably be future discoveries. At the moment they haven't been made, but if any other area of the world that's got gas, where gas or oil is discovered, it's very, very rare that it's a single one-off find. And in fact, I mean, even to the point that we already know that Tamar, Leviathan, Noah, and now Block 12 have all produced. So there's a very good possibility. I wouldn't put any money on them not finding any more, put it that way. But there's a very good possibility that future finds will be made. The liquefaction facility, again, this would leave an exploitable value or exploitable amount of about 5.9 trillion cubic feet if you took away the 1.1 trillion cubic feet for Cyprus's own domestic market needs. This is the, as I say again, this is the declared discovered and not what potentially is in the field. And again, I discussed the 30-year model being mooted here is the fact that it's based around the life of the equipment within the plant. Now, if you were to build a liquefaction plant, the LNG plant capacity, if you were to build a 4 million tonne per annum LNG train, you could run that for about 31 years and 5 for 24.7, which is probably the optimum period of time if you're looking at a 30-year life of the plant, because over 30 years you've obviously got the plant has to come down on occasion for planned maintenance and various bits. So 24.7 years is probably an optimum type of figure for the life of the plant. Another option would be to bring a pipeline to Cyprus. I've done quite a bit of research on what the costs are involved with the depths involved, and I'll move on to it, but I've used some of the figures from the Gauci project between Algeria and Italy as a base for that $2 billion figure. The cost of planning, designing and constructing a 5 million tonne per annum liquefaction facility, including the marine infrastructure, etc., will cost somewhere between $5 and $8 billion. Again, these are figures that I've been getting quoted from the industry. And the variation in price depends on the way that the plant is built and the level of modularisation, which I discussed in an earlier talk. If we were to stick build the plant, it would probably be closer to the 5 or 6 billion mark instead of modularising as much of it as possible. But it's open for review. It needs a 5 million tonne per annum plant. All the equipment exists now. There is nothing new. It's not brand new technology. So you're not breaking the barrier anywhere with any new technology finds or anything you need to actually source. Plants of 5 million tonne per annum now are relatively common, and so is the equipment that goes into them. So in total, you'd be looking at a complete development cost with an LNG facility, pipeline ashore, everywhere, somewhere between $7 and $9 billion. And the problem with this is that even in today's market, we probably wouldn't get much of this built before 10 years' time. Okay, there's also the fact that I've talked about the value of the gas. The gas, there are other people who take a chunk of that. Obviously, the people who found it, the people who operate the equipment that brings it ashore, and the government take their cut, so amongst many others. So there is a lot of people who have a hand in the pie, so to speak. And as we've seen, the current market value of the gas is around $23 billion. And you'd need then obviously to do a capex versus income cost comparison. And obviously if future finds are made, then they would obviously act in your favour because you've got the infrastructure to handle any future finds. Now, as I say, I've compared together some concepts of the pipeline. I've used the Gaussy project that crosses between Algeria and Sardinia, goes the entire length of Sardinia up to, I can't remember the name of the place, is it Olbia? It goes to Olbia, and from Olbia it goes to Piombino in Tuscany. But I've used this project was split into 3 sections. I've actually got friends working on this project. And it was split into 3 sub-projects. So, although it's a much longer pipeline than we've got here, the section between Algeria and Sardinia has got a lot of similarities. Although it's 100 kilometres longer than a pipeline would need to be from Block 12 to Cyprus, the depth involved is 1,000 metres deeper. The pipeline size is in fact almost exactly the same as the size that the pipeline would be from Block 12 to Cyprus. This is a 26-inch line. It's about a 36.7 millimetre wall thickness, and the pipe isn't buried over 40 metres deep. It just lays on the seabed surface. But it's been designed in such a way that the pipe has been stressed to actually allow for any seismic and current movements, and basically just sits on the bottom of the ocean, and it's been calculated where to anchor it, which it's actually very similar conditions as the Block 12 to Cyprus. Now, to give you some idea of that, it's been designed for 10 billion cubic metres. The idea being is to put 8 billion cubic metres per annum into the Italian network, and Sardinia would take a draw off of 2 billion cubic metres over that period of time. But this is almost identical to the size of the pipe that we would use here, because our demand is around about 8 billion cubic metres per annum, with a liquefaction plant. And we would then, you'd always design a pipeline with some added potential, in our specific case, because of future finds, you'd allow for some future possible expansion. But we could probably drop down to a 24-inch, even possibly a 22-inch line, but we know it can be done. It's currently estimated the final cost of the Gaussy pipeline is going to be in the region of about $5 billion. And the deep water submarine Algeria to Sardinia section has accounted for about, just over in fact, $2 billion worth of this. Now, take into account that this is all going ahead, it's being built now, all the work's been done on it. So the $2 billion for a pipeline that's 100 kilometres shorter, $2 billion is probably a very realistic cost value for the pipeline from Block 12 to Cyprus. Now, the timeline for the Gaussy pipeline, to give you some idea how long it took to plan and design this, the Gaussy company was formed in 2003. The feasibility study took about 18 months to 2 years, and feasibility work was still being done during the FEED stage. FEED stands for front-end engineering and design. And this took quite a long time because of the way the pipeline, one, had to cross Sardinia, and also the problems they were having with seismic modelling from Algeria to Sardinia. But the FEED, although it's a much longer pipeline, I say it was split into 3 sub-projects. This FEED here, at that time, all 3 sections of the project were all running concurrently. So there's an overlap of all of the project work all of the FEED work being done here on 3 different projects. But the time frame was still, for each individual part of the project, the time frame was still at least 4 to 5 years for each section. Okay, now the signature agreement between Algeria and Italy was signed in 2007, and the authorisation procedures, which wouldn't affect what was happening here as much as it did there, because this went through, I think, 13 different political regions of Sardinia, and they're Italian. So you can imagine how long it took to actually work out who was going to get what. But that was all going on while the FEED was happening. So it's not as if this was taking up time that, or extending the time. It was all still being done while the engineering design work was being done. They didn't even decide on a final route until 2009 because of the level of modelling that was being carried out. Construction started last year and is expected to take around about 2.5 years, and expected operational start-up date is 2014. This is 11 years. So this just puts into perspective, what I'm trying to, is to explain how long it takes, or it can take, for things to get done. As I've said, it's not a completely fair comparison, as the Gaussy pipeline is considerably longer and traverses the entire length of Sardinia. and as I said, it's split into 3 primary sub-projects. And the big thing to note here, though, is that both Algeria and Italy have a huge amount of world-class experience when it comes to building oil and gas infrastructure. Saipem are the guys with the biggest cranes in the world. They own 2 cranes called Saipem 7000. They are the biggest cranes in the world, and they can lift 14,000 tons in a tandem, which is one very, very big weight. And in fact, Saipem 7000 can actually be converted to a pipe-laying vessel. And it's this type of equipment and knowledge that Italy has already to start with. We don't have that here. We don't have it. So we'd have to go on an educational program for people to understand how we're going to do it or how it would be done. We've mentioned the AC requirement is 1 billion cubic meters per year. That's the capacity once they've installed Unit 6 at Vasilikos. At the moment, these are what we call dual fuels. They run on distillate, a liquid, or they can run on gas. And the whole idea with the EAC was that they would eventually convert all of the units to gas by around about 2015. I think the first unit's going to be up and ready the latter part of this year or early part of next year that would be able to run on gas if there was gas available. As we've seen, the time frames, even with the pipeline, are considerable. And even if Cyprus adopted a fast-track approach to building a pipeline, it would not be designed and installed, I don't think, much before 4 years. And that's been extremely optimistic. But 4 years is probably the very earliest we could get one in. I'm pleased to dispute if I say anything that you think is completely wrong, Greg, but... okay. There are other considerations. If we did have a pipeline coming on shore, who would own it? Who would pay for it? Would we design the pipeline for possible LNG use and domestic market? And who would operate and manage it? And what land-based facilities would be required? Now, the land-based facilities, again, it's the same thing. And it's an ownership issue. Who would own it? Who would manage it? Who would operate it? And if we were just bringing natural gas on shore, would we want any buffering capacity? Depending on the pressure coming out of the well, I believe is something in the region of about 400 bar. The pressure drop on that line between block 12 and here, you lose about 0.6 of a bar per kilometre on a 16 to 20 inch line. So you've got some pressure drop that you'd lose. You'd have to do some calculations to decide if you needed to recompress at this end. To put in perspective what 1 year's supply of gas would look like, it would all fit into one container at ambient pressure if the container was 1.5 kilometres in diameter and 600 metres high. That's how much gas. And I've actually laid it over the top of Vasilikos to give you some, from a circular point of view, some perspective on the amount of gas the island needs in a year. Sorry? No, it's next door. Okay, so that's what it looks like in perspective. We don't normally store gas at ambient pressure anymore. They used to in the UK, but we don't store it under ambient pressure anymore. We normally store it in horizontal vessels called bullets, or we refer to them as bullets, or we put it inside spheres, depending on the pressure. Normally, if it's very high pressure, then it would go into spheres, and we would normally take those up to 200 bar. Okay, yeah. The more you squash the gas, Boyle's law simply says that you double the volume, double the pressure, you double the volume. But looking at 1 month's capacity here, the pressure would require a sphere of 100 metres diameter. So that would obviously need to be split. If we just wanted 1 week's requirement at 200 bar, the sphere would need to be 30 metres diameter, which is pushing the envelope on the size that we normally take them to. So one option would be to consider monthly deliveries and storing this gas in 12 spheres of around 44 metre diameter each. This is just what you need if you were just to simply bring natural gas onshore but not from a pipeline. And This moves around a bit, but the whole presentation moves around a bit because there are various different options. Either bringing natural gas onshore, and I'll show you later, there's a possibility of bringing it onshore using what is referred to as, it's a trademark name called Energy Bridge by Accelerate of the States. And they can actually bring gas onshore as natural gas from a remote location offshore. And in fact, there's one, Accelerate's Northeast Gateway Bridge in Boston, is where the gas actually comes onshore is from a buoy that's 17 miles offshore. So that way you limit the amount of infrastructure on the land. You don't have heavy civils and marine costs when building a terminal onshore to collect the gas, and you can have it delivered offshore where you can't even see it, which has got possibilities. But the problem is they can only do that now with natural gas, and if you did that with natural gas, you'd have to come up with some method of storing at least a month or at least 2 weeks supply of gas. And that's the physical constraints on the size of the equipment you would need onshore. So what I was saying there is all I'm trying to show is we simply wanted to import natural gas without a pipeline. There are numerous options available right now, and really a feasibility work should be actually getting worked on right at this moment. This is what I was talking about from the offshore facility. This is a floating liquefied natural gas floating storage and regasification unit. What this thing does, it goes to the well, it pulls gas out from where the well is, it then it liquefies the gas at sea. It then travels with its liquefied natural gas as a cargo and pulls up to one of these turret mooring facilities. This normally sits about 30 metres down in the water. It has a small buoy on it. The small buoy is drawn up through a hole in the ship that on a floater we normally call these things moon pools. But the turret is then pulled up through the ship and connects to the ship, then converts the liquefied natural gas to natural gas and sends it through a pipeline onto shore. And this is what I'm saying. This ship, this buoy, could be located up to 17 to 20 miles offshore. So you wouldn't even see the ship coming in to collect it or deliver it. Your minimum infrastructure here is simply doing a beach crossing and bringing a pipeline on shore. Your major expenses from the 40 metre to beach level where you've got extensive infrastructure. But it's only one pipeline. So the effects on the beach are minimal. And because that's the size of the things. So this is a liquefied natural gas plant on top of a ship that has got regasification ability, and in here are the storage of the LNG, is where the LNG is stored as a liquid gas. Okay, this is Accelerate's LNG and Energy Bridge. This is exactly what I've been talking about, is that they've got a number of carriers that can do this, and even to the point that the Cyprus field, you don't need to have a permanent structure over the top of it, or manned permanent structure. You could have, it can be done through various different means. This is just one of them. But the concept of what in the oil business we call them FPSOs, floating production, storage and offloading vessels. And exactly the same concept is now being used for LNG. But the LNG is actually being produced at sea. Okay, now this is where the cargo can be discharged as liquid at a traditional LNG facility, regasification terminal. But this you need marine infrastructure. At the moment, Accelerate haven't designed, as far as I know, haven't designed a system for actually pumping liquefied natural gas onshore from so far out at sea. As I've said, there is one that I'm going to show you on here that's in Boston Harbour or Boston Bay, that's 17 miles from the shore. Now there isn't a system at the moment that can pump 17 miles of LNG, but it can compress 17 miles of natural gas. So the cargo can be discharged either as a liquid at a traditional LNG regasification terminal or as gas via Accelerate's Energy Bridge buoy-based STL. The STL is a turret loading system, and via the onboard high-pressure gas manifold. So you can send it ashore at pressure, and if you've got somewhere to put it. If you've got a huge big gas network like they've got in the States and throughout Europe, you just pump into the gas system. You pump into the network. But we don't have that on Cyprus. If we had a gas, there's only 1 million people here. We don't have a gas network. Normally most gas networks are at such a pressure you can just pump straight into them. But we don't have that here. So we could either go for the storage method that I've discussed earlier, where you need a huge big amount of storage, or you can actually build buffering into the system. But you'd have to then maintain your entire gas system at around about 200, or at least somewhere between 100 and 200 bar. And this is what it looks like. That's all that sits out at sea, is this buoy. And that buoy, underneath there is the turret system. This gets drawn up into the ship, and this is the actual connection. Actually gets drawn up into the ship, and this is how the gas would then get sent ashore. This is the one that's in Boston Bay. And the reason it's there is because of the price of real estate in northeastern America. There's no disruption to anything that's very minimal disruption to what's going on the shore, and they're not taking up a huge amount of real estate by building a conventional jetty and the dolphins to collect the gas from the ships. Okay, where are we? We've seen that there are potential disadvantages with regard to storing natural gas that was delivered by any other means. If a pipeline was installed in the future, the bulk of any gas storage equipment, spheres or bullets, would become obsolete. This is another thing. If you bring natural gas on in this method that I've just shown, and you decide to build a big gas network infrastructure, technically it would become obsolete, depending on how much you wanted to integrate it into your gas distribution pipework for the DEFA planning for the island. So this is another study that could be should be actually be getting looked at. What I've gone back to is I've revisited the possibility of building a regasification facility. One of the questions we get asked is how much of the how much of the regasification facility could be incorporated into an LNG or a liquefaction facility. Primarily, all you could really say, all you'll keep from it is you'll keep whatever the infrastructure is for the loading and the LNG storage tanks, but then take into account that these two are around about 70 to 75% of the total cost of this entire development. I got a quote on these tanks this morning, and I've been told if they were being built not to Shell's specifications, but to meet the international requirements for storage of LNG, these cost between $650 and $750 per cubic metre stored. So for the size that we'd need on a Cyprus, I've got these coming out at around about up to $270 million. So the total regasification facility shouldn't cost more than $500 million, $500 million. And you've still, as I've said, the tanks, what I've done is I've looked at it as the tanks being of use at a later date if a liquefaction plant was built. Oh yeah, I'll say here, I've received an email this morning from one of the world's biggest manufacturers, and these are the prices they've quoted me. $650 to $750 per cubic metre. And I've worked those figures out on what the island's requirements are. To configure the tanks, what I did was I looked at a diameter of 40, a height of 35. If we had 2 tanks like that, we'd need 19 deliveries per year of gas. The 2 tanks here I've shown 70 and 75 don't exist yet. They're not. This one's in the planning, but they don't actually exist yet. The biggest tanks we've got at the moment are somewhere between 199 and 250. But what I've done is I've just simply tried to show the size of the tank. So I've looked at about 190,000 cubic metre tanks that would require, we'd need 2 of them, 5 deliveries a year, and the weeks between deliveries are 11. The ideal tank size for Cyprus would be somewhere around there, and most of the world's LNG carriers, there are some super huge ones around that now carry up to 250,000 cubic metres. But the bulk of the world's LNG fleet are all around this sort of size. So, or 75% of the world's fleet is around about this sort of size. So these would be the sort of size you'd look at building tanks, because you know that you can take a full load from an LNG carrier. And they're the figures that I've got prices on this morning. And to give you some idea, these 2 tanks here at Sakhalin are 190,000 cubic metres. These are exactly the same sort of size that I would say would work for Vasilikos. Right now as storage for LNG with a regasification facility, and in the future. You'd still be left with some equipment, but a regasification facility is primarily vaporizers or heaters. What you do is you have to heat the gas up to bring it back to ambient temperature, and then these are simply regasification facilities. These, where I said this, we wouldn't necessarily need a full-time or something permanently over the well. This is something that's permanently over a well, but a lot of it these days is all done on what we call umbilicals. This is turret mooring, where the same ship, the FPSO with a turret mount, comes over the well, regasifies or liquefies the natural gas at sea, and then sails ashore. Okay, before any decisions we made, the various options open to the EAC. When I say EAC, I also mean DEFA, because I did a very similar talk for at the request of the EAC a few weeks ago, where they wanted to know what their options were. And I obviously went through all of these with them. But then EAC said to me, we don't even make the decision. We are forced now, we have to buy our gas from DEFA. So technically, it should be DEFA who are making these decisions. So I've putting aside any commercial aspects on gas supply agreements, because at the time when I gave the talk with the EAC, Noble hadn't stated that hadn't confirmed the fines in Block 12. So I broke the various options they had down into 3 categories as fast track 15 to 30 months. 15 being using the Accelerate Gateway possibility, minimum infrastructure costs, but you could actually get something built, you could get natural gas onto the island somewhere between 15 and 30 months. And then I've looked at the medium term and then the long term option, obviously being towards a liquefaction facility. Okay, fast track option 1, natural gas with 1 billion cubic metre handling capability. Gas delivered by pipeline from LNG FSRUs using turret mooring. This is the one that I'm talking to Accelerate on this, and they said if you had a green light on all of this, they could probably get something done within 2 years. So there is a possibility that if that was the one option that everybody wanted to go for, then it could be done. The disadvantages to it are that the energy would probably need to be recompressed and stored in spheres or bullets, which I've discussed. The only recommendations can be made is that they need to do a high-level concept study, which shouldn't take longer than a month. That really needs to be getting done now. I'm not sure what the team of experts are doing that have been appointed by the government, because everybody that I talk to who supplies major LNG equipment haven't been getting calls from anybody. So I'm like, I don't understand why they're not getting calls. Natural gas facility with gas is another option, is to bring natural gas coming from LNG FSRU with conventional infrastructure. Now this takes a lot more time to build. The disadvantages are exactly the same as option 1, that any long-term facilities you build, you'd have to decide if you needed to incorporate them into the gas transmission network for the island. Again, this is one option, but while doing this one, you would actually be looking at what the costs are for building an onshore facility for deep sea ships. Medium-term option 1. This is a regasification terminal. Now, talking to the manufacturer of the tanks this morning, they said that they could build these tanks at 190,000 metre cube within 4 years. But that would be without having worked on a lot of these projects over the last couple of years, and the biggest ones in the world. The problem is that we normally have to, the major owners of these pieces of equipment, people like Shell and BP, tend to stipulate their specifications on you. And the specification and signing off process. That takes time. It can take a year just to get sign off on a design. You've also then got to do everything to the way that you're being dictated to by the majors. Now, one way or another, I would assume that one of the majors is going to get involved in this, which means that they are then going to dictate to you what specifications you work to, how you design it. So you're then going to go back to base. And normally, we wouldn't install an LNG tank within 6 or 7 years. But you could do it in 4, and I've had that from the horse's mouth, from the actual manufacturers of these tanks. So it depends on how somebody would want to play it. But that's it. The disadvantages are, is because of the size required, design and planning and construction, this would probably not be ready for commissioning and handover. I've said anything less than 3 years. I'm being extremely conservative. Period of time required to design and plan them, it's just a very long time. And it's major capital costs. You've got to spend $300 million, the best part of $300 million just for 2 tanks. And you're not going to be able to do anything with them for 4 years. Again, I'd recommend they look at this. I really believe that the regasification facility is the best option for Cyprus, because we can use the bulk of the major equipment at a later date. We're literally only writing off about $150,000 worth of equipment, if that. Sorry, we're writing off a lot of money. $150 million worth of equipment, but over the period of time, we're going to be without gas here for at least 6 years. The difference in time between building a regasification facility and a liquefaction facility is about 6 years, if we pulled our finger out and started doing something about it now. So for 6 years, we're going to still be running on liquid distillates and paying through the nose for our electricity. I think that's probably why the EAC haven't come here today. Okay, medium-term LNG regasification terminal with marine infrastructure. Again, it's the same thing, regas. Natural gas pipeline from Cyprus fields, probably linked to Israeli fields. Advantages to this is it's a permanent feature. It's expensive, but as we've shown with the Gaussy project, we're looking at probably around about the $2 billion mark. And if we really did pull our fingers out, we could probably do it in about 4 years. We'd be pushing our luck to do it any sooner. Then this comes up with sizing questions, including possible future needs. Would you put the pipe in? And you'd only need to bring a pipe here of about 8 to 12 inches, but you would normally lay a pipeline in that deep, that diameter, in that depth of water, with the amount of hassle you've got to go with it, just to bring it on for the domestic market. So you'd probably size it, and you can put through more gas through it at a later date, and therefore run an LNG facility off of it. Again, this somebody needs to do high-level feasibility with this now. Okay, an LNG liquefaction plant that can liquefy Cyprus gas for future gas from Israel. Again, this is the liquefaction discussion. But at the moment, where we are is I personally believe that the best strategy we could have would be to build a regasification facility as soon as possible, and design that around as much of the equipment being used at a later date in a liquefaction plant. And that plant could be designed to accept gas, I reckon, within, as I say, 4 to 5 years, if work was started on it immediately. Oh, there's just a quote there from Syrian Wood. I don't know if any of you have heard of the Wood Group, but the Wood Group started off in the 60s as a fishing company in Aberdeen, fishing in the North Sea. Ian Wood went and studied philosophy, and his dad asked him to come into the business when he wasn't feeling too great. Well, Ian took the business and started supplying the rigs in the North Sea from the 40s right the way through to current day. What started off as a 2-trawler fishing fleet, the Wood Group last year rolled 2.4 billion and has 14,000 employees, and in fact own the company called MSI Kenny, who are doing the modelling for Noble of the subsea pipework, I believe. MSI Kenny? Tommy, yeah, I know the guy who's doing it. Tommy Groller. Yeah, anyway. But the Wood Group owns the company that's actually doing the subsea modelling for Noble. And Syrian Wood is his advice to anybody who's looking at moving into the oil and gas business is take a global perspective of it and not a local one. Okay, thank you. Any questions?